Okay, I'm back, and now we want to go to part two of the lab, and we're going to explore what do we mean about the electric field of a charge. And so you're going to be going to PhET and then charges and fields. So once you have Googled that, then you should come to something that looks like this, and then you're going to turn it on, and then you'll have something like this. Okay, so this will be your picture. So I'm going to minimize this, and now I'm going to minimize this, and now we're going to go back to the lab. So this is part two, the electric field. So what do we mean by an electric field? An electric field is going to be a region of space that is going to surround an object, and then when you put another object into that field, it's going to experience a force. So since you're more familiar with gravity, I thought that we would introduce this by talking about the gravitational field of the Earth. So if you look at that picture there, you've got the Earth, and then it shows its gravitational field. So how do we map the gravitational field of the Earth? So all we do is we're going to take a little mass and we're going to drop it. So we let go of the mass and it falls to the Earth. But if you live over here in Australia and you're taking your shrimp and you're putting it on the Barbie, then if you let it go, it doesn't fall down, it falls in that direction. Of course, they don't think it is falling in that direction. They think it falls down, but in reality, it's going here. And then if you took an object over here and you dropped it, it would go in this direction. So if you made a whole bunch of arrows, all the possible directions that an object could fall, it would make a picture like this. And it kind of looks like spokes on a wheel, but actually it's more like a pin cushion, because this is what it looks like in 2 dimensions, but in 3 dimensions you can imagine that some of the pins would be coming in at different angles on it, and so in 3 dimensions it would look more like a pin cushion. But all of those arrows represent the gravitational field of the Earth, and then this is going to be caused by the mass of the Earth. And then when you take another teeny tiny mass and you place it into the field, it experiences a force. Now a force is a push or a pull. So in this case, it's the pull of gravity. But a force could also be a push. So if you are pushing on your car to get it to roll forwards, then you're exerting a force on it. So that's what we mean by the word force. So that is the gravitational force. Now, you can forget about it, because we're going to be talking about the electrical force and the electrical field of something. So the electrical field is going to be given by the letter E. So capital cursive E is going to stand for electric field. So I always try to use one letter to represent different concepts in physics, so that in some textbooks they would use a capital regular letter E for electric field, but we're also going to use that for energy in here. So I try to use unique letters, so that's why I'm going to use a cursive E to stand for the electric field. Alright, so now we're ready for the simulation here. So we're going to go down to here. And so now let me just put up the simulation again. All right, so we've got a positive charge that you could put up here. You've got a negative charge that you could put up here. And then this yellow thing is a teeny tiny positive charge. So let's take the red one. Or actually, let's take the negative one. We're going to take this negative charge and we're going to put it in there, and then look at all those arrows. So those arrows represent the direction of the electric field. And you should also notice that some of the arrows are bright and then some of the arrows get dim. What do you think that means? Okay, it means the further away that you get from the source of the electric field, the weaker the electric field gets. Okay, it's just like gravity. So the further away from the Earth you get, the weaker gravity gets. So the further away from an electrical charge you get, the weaker the electric field gets. Now, where do you think that these arrows came from? How did we map those electric field lines? Well, we did it with a teeny tiny positive charge. So in the same way we take a teeny tiny mass and we let it go and we follow the direction it goes, and that's the electric field, then we can take this teeny tiny little charge, and if we put it over here, you see it's got this red arrow. So that red arrow represents the electric force that it's experiencing. And do you notice what direction is it going? It's going down. Okay, and then let's take the teeny tiny electrical force or electrical particle and let's put it over here. So do you see now that the red arrow is pointing sideways towards the blue thing? And then we could take it and we can put it down here if we want. And then you see that again it changes. So this teeny tiny electrical particle, which is going to be positive, we always use a positive test charge, and that's what the yellow one is. And then one of the things you should know about electricity is opposites attract. So a positive charge will be attracted to a negative charge. Well, what about a positive and a positive? Well, they would repel each other. And then what about a negative and a negative? Well, they would repel each other. So that's very important. Make sure and put that in your notes. So opposite charges attract, like charges repel. So since this is a teeny tiny positive charge, and then this is a negative charge down here, then they're going to be attracted to each other. So you see the red one is pointing towards the blue one. And then look at what happens if I take this and I move it further away. So do you see that the red arrow got smaller, which means that the force of electricity got smaller. And what did we say about the electric field? The electric field also got smaller. Okay, now one thing I wanted you just to try out is let's take the yellow ball and let's put it away. And then instead of, let's take the blue one and we could put it away. And then let's put the red one. So if we were to take the red one and put it out here, I want you to predict before you let go, I want you to predict what do you think the arrows would look like. Okay, did you do it? Okay. So do you see that it makes exactly the same picture, but now look at what the arrows are doing. The arrows are pointing outwards. Can you explain why? How did we come up with those arrows in the first place? We took a teeny tiny charge and we put it out here and we observe what direction does it want to go. So this thing is positive, the red one's positive, the yellow one's positive, and so like charges repel. Okay, and then you should also notice that if I take this and I move it further away, do you see what the red arrow is doing? It's getting weaker. So there's the electric field of a positive charge. And then I also wanted you to just play with it. So if I take two positive charges and I put them, well, I'm not going to do it. So you do it. So take another positive charge and put it out there and observe what does the new electric field look like, and then you could also try it with a positive and a negative charge. Now this one's really important, so I definitely want you to do that one. So take a positive and a negative charge and put them out there and observe what the electric field does. So it's going to make a particular picture, which we're going to come back to that picture when we do magnetism. And we talk about what does the magnetic field of a bar magnet look like. And it's going to look very similar to that picture. All right, so I think that we're finished with this simulation. And so what I want you to do, though, is you got to fill everything out so that remember to answer all of these questions. Oh, okay, here's another thing. It says to make a snippet of something that you're going to see on the simulation and put your picture here. So I need to tell you, how do you do that? All right, so now let's go back and put the simulation back on there. So let's pretend that we want to make a picture of this and we want to insert it into the lab. So what we do is we're going to make a snip of it. So you see this blue thing down here. So we're going to click on it. Then we're going to type in the word snip, S-N-I-T. And it says snipping tool. Okay, then I'm going to click on it. Okay, and then on your computer screen, there it is. So on your computer screen, it's going to look something like this. All right, now we're going to click on New. So we're going to make a new snippet. So click on that. Okay, and you see it gets a little bit dim, and I've got some crosshairs. So I'm going to put the crosshairs up here. Now I'm going to click on it, and then I'm going to pull down and then over to the side. And I can even put my lovely face in there if I wanted. Don't do it, but you can. And then I'm going to release it, and there you see that it just made a picture. I got it, so I don't care about that, so I'm going to get rid of that. So there is a snippet of the screen. Oh, it didn't even put me in there. That's interesting. So just as well. So now let's say that we want to take this and we want to put it into the lab. So we're going to go back to the lab. Okay, go back to the lab. Okay, click on the page, and now we're going to do a control paste. So press the control button down, and then at the same time press the V button. Okay, there's my picture. But what's the problem? The picture's too big. So I'm going to go up here, and I'm going to grab the picture, and I'm going to keep doing this until it gets small enough to fit in the lab. Okay, so something like that. Now we could also crop it so that if you were to do a right click, so do a right click on this thing, and let's see, you can crop it. So down here at the bottom it says the word crop, and then I'm going to click on that, and now I'm going to grab this corner and I can make it smaller like that, or I could also make it smaller like this. So I want you to play with it, and then so you see how it cleaned it up. So you can crop your picture so that it fits onto the screen. So I want you to play with the snipping tool and then make a picture of something and put it on there. Now you can do this on any picture on your computer. You can go to the internet and find pictures, and you can take snippets of them and then put them into documents. So it's a very, very useful tool. Okay, so now I think that you should now have enough information to answer all of these questions about the electric field. And remember, do it in red so that I can know what you wrote down. All right, so now we're ready for part 3, which is separation of charge. So we're going to take a break, and when we come back, we will show you that simulation, and then we'll go through that part of the lab.